Okay, so today we are going to talk about how to deal with situations where there is motion. Okay? That means that now we are not talking about equilibrium, but we are talking about a situation where the object which is subjected to various forces under the action of these forces will start to move, right? So wait, 1 minute. हाँ मैं लास्ट क्लास और इस क्लास का स्लाइड एक साथ भेज दूंगा अभी भेज दूंगा उसके बाद हाँ so the way to handle situations where there is going to be motion, right? We are going to categorize the situation given to us in three different ways. So if motion, well, I should not really write motion, I should write acceleration is not equal to 0. So if we know that equilibrium is not being maintained, then there are three options, three distinct cases. Yeah, right. So case one is we know the direction of, let me write it right, we know the possible direction of acceleration. Number two is that we can work out the direction of acceleration. And number three is we do not know direction of acceleration. So I'm going to tell you all the three cases, but you always will have a choice where you can say that, look, I don't know the direction of acceleration, and you can actually work out the direction of acceleration for every question. But that would be sort of overkill because in most of the problems, you will be able to work out the direction of acceleration. It will be sort of common sense. But if you don't want to rely on common sense. You don't want to have any uh, you don't want to have any uh, pre-conclusion about the problem. Then you can use the third वाला method where I will tell you कि आपको कुछ नहीं मालूम है तब कैसे approach करना. Okay, so let's start with the first one. Number one. So there is something called constraints, right? And the word constraint in English means obstacle, or uh, in this case, uh, in this case, a more accurate translation would be, Radhika has said, limitations. So constraints means limitations. किस चीज का लिमिटेशन, किस चीज की लिमिट. So supposing that I tell you that there is a horizontal fixed surface, and on this horizontal fixed surface I have a block of mass m, and on this block of mass m I am going to apply a force. Okay. Then the limitation or the constraint here on the block, the constraint is always on the object which will move. The constraint on the block is, can you guess what it is? हाँ भाई, फ्रिक्शन कहीं नहीं है, फ्रिक्शन अभी हम बात ही नहीं कर रहे हैं. The constraint on the block is what? The constraint is always on the motion, right? So can you just look at this problem and predict कि motion कैसे होने वाला है? We are not asking the question force is enough, force is not enough, friction is there, friction is not there. No. अगर motion हुआ तो इस ब्लॉक का मोशन कैसा होगा, और इस ब्लॉक का मोशन कैसा impossible. That is what you are supposed to sort of conclude from common sense. So common sense is telling me that there is no possibility of this block moving up and down. So this block can only move along the x-axis, cannot move along the y-axis under the given situation. If I change the situation, if I change the force, then this may change. But under the given situation, the constraint is that motion is confined to x axis. ठीक है ना? हाँ, नेगेटिव पॉजिटिव से मेरा मतलब नहीं है, मेरा मतलब है हॉरिजॉन्टल मोशन होएगा. What I mean is that there will be horizontal motion. और वो राइट में है, इस केस में राइट में है, राइट. हो सकता है कोई और केस हो जहाँ लेफ्ट में है, हो सकता है कोई और केस हो जो, हम तो केवल 2 डायमेंशन की बात कर रहे हैं ना, असलियत में तो 3 डायमेंशन है. तो अगर आप के सामने एक बॉक्स रखा है, आपने उसको किक किया. If you kick it, then it can move anywhere along the floor, right? Depending on how you kick. Provided, of course, that your kick imparts a horizontal uh, momentum to the object. Right? So this is a obvious constraint, right? I mean, we know the possible direction of acceleration in this case. I'll give you another example. So we have the vertical ceiling fixed. From that vertical ceiling, we have pulley, and there is a string on the pulley, and there is a block of mass M1, and there is a block of mass M2. हाँ, नेगेटिव में नहीं मूव कर सकता है भाई. एक्स एक्सिस के अलॉन्ग मूव करेगा ना, पॉजिटिव या नेगेटिव. यहाँ पे when I leave this, अभी रुक जा हार्दिक, अभी कर रहा हूँ. When I leave this system, when I leave this setup, when I release this setup, what can you tell me about the motion of M1 and M2? What can you tell me about the motion of M1 and M2? So the motion of M1 and M2 should be obvious. There should be no confusion. If this is the x-axis, this is the y-axis, then the motion of M1 and M2 will be along the y-axis. Please notice my words. I am releasing the system. I am releasing the system. That means I'm not kicking it along the x-axis. I am just taking the system and releasing it. So this guarantees that the motion of M1 and M2 is going to be along the y-axis, and there is no possibility that motion will be along the x-axis, right? So such things we expect that you can conclude without any other input, without me telling you that this is going to happen. I'll give you another example. So on a horizontal fixed surface, we have inclined plane of angle theta. हाँ, अभी सब बता रहा हूँ भैया मैं. And on this inclined plane of angle theta, we have this block. Now what can you tell me about the motion of this block? I release the block. Okay, I release the block. What can you tell me about the motion of this block? XY plane से थोड़ा और ऊपर उठिए. Now you are not in class 10th anymore. What is the motion? What is the direction of motion of this block? Ah, Khushi, very good. This is the answer that I was actually looking for. the motion of the block will be along the inclined plane. I am going to choose this as the y-axis. I am going to choose this as the x-axis. Okay, remember that your xy axis are not bound to be horizontal and vertical. They can be in any orientation. In fact, there is a question. I have to discuss this. There is a question in your exercises, which is something like this. So there is a string here, point object here, and another string here. This angle is given as theta, this is m. They are telling me that this is tension here is T2, tension here. So when you draw the FBD of this problem, then you have to draw T2, T1. Yes, so this is correct. This is correct. But if you draw mg, but if you draw, let me do it here. If you draw T1, T2, mg, then this is incorrect. Okay, although the answer that you will get will be correct in the second case as well, but yeah, incorrect because forces must be as they are in the original diagram. राइट तो ओरिजिनल डायग्राम में mg इधर लगा हुआ है, T2 इधर लगा हुआ है, T1 इधर लगा हुआ है. So although this will give you the right answer, right, and the thought process behind this was of course absolutely brilliant, but unfortunately it was wrong because you are supposed to change the orientation of the axis. Okay? You are supposed to change the orientation of the axis. So you can take the x dash axis here and the y dash axis here. But you cannot change the orientation of the forces themselves. That will produce huge amount of confusion, and therefore it is not. So here also, in the second case, remember that I will not change the orientation of the forces. The forces will remain as they are. I will change, however, the orientation of the axis. And once I have changed the orientation of the axis, then I can say that the block of mass m is constrained to move along x-axis. Blocks are constrained to move along y-axis. Okay. Now, of course, you may ask the question कि यहाँ अगर मैं normal xy axis ले लूँ तो क्या होएगा? अगर आपने normal xy axis ले लिया, then the answer will be exactly what you were telling me before, that the motion will be in the xy plane. The motion will be along the x and the y axis. Yes, absolutely right. But we don't want that because the motion is down the inclined plane. This fixed inclined plane will ensure that the block is moving along the inclined plane, and therefore I will, for my own convenience, choose an axis which is along the inclined plane. Therefore, I am dealing with one-dimensional motion. If you draw the horizontal XY axis, then you will be dealing with two-dimensional motion, which is always more complicated, right? So you will be complicating your lives if you deal with horizontal and vertical XY axis. आया समझ में जो मैंने बोला? Right. हाँ, correct है Radhika. I'm not saying it is incorrect. You are absolutely correct in saying that the motion will be along the XY axis. Okay. Of course, I can never argue with correct and incorrect. What I'm trying to show you is what is the easiest way out. Can you choose the horizontal vertical XY axis? Yes, you can. Can you draw FBDs and can you? Bilkul, it may not be the chosen. Yes, your XY axis may be different from my chosen XY axis. What I am simply trying to say is that there may be an XY axis which will give you the solution in the most rapid manner. Okay? And I'll show you an example. ये देखो, ये वाला क्वेश्चन हॉरिजॉन्टल एक्स वाई एक्सिस से अगर हम सॉल्व करेंगे ना तो हालत खराब हो जाएगी. कैसे हालत खराब होएगी? अगर ये एंगल थीटा है तो ये एंगल थीटा होगा, तो यहाँ पे आएगा T2 cos थीटा, यहाँ पे आएगा T2 sin थीटा, और फिर अगर ये एंगल थीटा ये 90 है तो ये 90 माइनस थीटा है, तो ये कंपोनेंट T1 का आएगा T1 sin थीटा, और यहाँ पे कंपोनेंट आएगा T1 cosine theta. So the equations that you will end up with will be mg is equal to T1 cosine theta plus T2 sin theta, and the other equation that you will end up with will T2 cosine theta is equal to T1 sin theta. Right, now you are solving this for T1 and T2, right? Given है प्रसन्ना, क्वेश्चन में आप देखो तो if you solve, of course you are going to get an answer which will be the same as the answer that you will get if you take the green XY axis. And if you, complicated and correct, yes. So if I take the horizontal XY axis, I will get a complicated expression, but ultimately I am going to get the correct answer. And if I take the slanted inclined XY axis, I am also going to get the correct answer. In fact, I can take any other axis that I wish. The level of complication will rise. But there is one orientation of the axis that gives me the answer in the fastest time, and that is the green wala axis. Right? The green wala axis gives me the answer in one step. So this is what we have to. This is what we have to. This is what we have to understand. This is what I am trying to show you here. So green wala axis we will not consider. हार्दिक क्वेश्चन देखना है यार. आपने हैव यू ट्राइड हार्दिक दीस क्वेश्चंस या केवल टाइप करने में मजा आ रहा है? तेरे को किया है तूने? तेरा होमवर्क तो नहीं आया मेरे पास? लेक्चर 1 का भी होमवर्क नहीं भेजा ना मेरे को? आज मैं डालता हूँ ग्रुप पे मैं नाम. लेक्चर 2 खोल के देखो, लेक्चर 2 का प्रॉब्लम है. ओके, सो constraint is obvious. That is the first case where we know the possible direction of acceleration. common sense से just by observation we can conclude that this will be the direction of acceleration is the first case. Okay. The second is where we can, इसका क्या मतलब हुआ कि we can work out the direction of acceleration. We want a situation where we can work out the direction of acceleration. ये कैसे करें? So in this case, what is going to happen is that supposing we have a horizontal fixed surface and take just 1 minute. I'll just put on mute for 1 minute and come back. Sorry. So there are cases where we can actually work out the direction of uh, acceleration. So I'll give you a couple of examples. Example number one is that we have a block of mass m like this, and on this block we have another block of mass, let's say m1, and this is connected via a pulley to another block of mass m2, let's say, and there is a force F which is pushing the whole system like this, right? So out of these three blocks, M, M1, M2, can you tell me out of these three blocks, M, M1, M2, can you tell me for which blocks the acceleration direction is obvious and for which block or blocks the direction of acceleration has to be worked out? For which block or blocks is the direction of acceleration obvious and for which block or blocks the direction of acceleration has to be worked out? Okay? So for this and this, the motion has to be along the x-axis, right? For capital M and for M1, the motion has to be along the x-axis. But M2 के लिए we will have to work it out. Why? Because as capital M moves along the x-axis, M2 will be also moving along the x-axis. And M2 can also move in the vertical direction. So it can also move along the vertical direction. यहाँ पे हमको वर्कआउट करना पड़ेगा।
सर हम लोग मास M1 का भी नहीं बता सकते अभी, बिकॉज डायरेक्ट कांटेक्ट फोर्स जो लग रहा है वो सिर्फ कैपिटल M के ब्लॉक पे लग रहा है ना, डायरेक्टली तो M1 पे नहीं लग रहा, तो हम लोग फिलहाल तो कुछ कमेंट नहीं कर सकते उस पे।
इसकी बात कर रहा है
सर M1 की बात कर रहा हूँ।
तो M1 ऊपर नीचे कूद सकता है क्या?
सर अगर वो उसी पोजीशन पे फिक्स रहा और आपने नीचे वाले को धक्का दिया तो हो सकता है।
नहीं हो सकता।
नहीं हो सकता, ओके।
ऐसा करना, तू अभी अपने कुर्सी पे बैठा है ना?
हाँ सर।
तो अपने बेड पे रस्सी बांध, ठीक है, एंड यू सिट ऑन योर चेयर एंड ट्राई टू पुश योर बेड विद द रोप।
अच्छा ओके सर, समझ गया।
So another case is this. अब यहाँ पे हम M1, M2, M3, M1, M2, M3 के बारे में क्या बोल सकते हैं? ओह सॉरी, ये मैंने सॉरी, ये तो ऑब्वियस वाला बना दिया। सॉरी, सब कुछ अलॉन्ग मोबाइल है। सॉरी। हाँ बना रहा हूँ, रुक जाना। हाँ fixed horizontal surface, fixed vertical surface. So M along the x-axis, right? Capital M का motion will be along the x-axis, but small m का motion will have to work out. हाँ, xy plane में होएगा, so we'll have to work out the exact direction of acceleration, right? सही बात है सर, कोई फोर्स नहीं है कर रही। नहीं प्रतीक्षा, along the incline नहीं बोलेंगे ना, क्योंकि ये incline itself मूव कर रहा है ना, ये फिक्स नहीं है स्मॉल m। How will M be in POS? ये क्या लिखा है तूने मेरे को नहीं समझ में आया. If you want me to draw using another color, I will draw. This is an incline. Okay, this is a movable incline. It can move. There is no friction between the inclined plane and the. किसकी बात कर रहा है भाई? Small m xy axis के along move करेगा, yes. And later on we'll figure out कि ये small m किस direction में move करेगा. Why we will not motion? ये क्या क्या लिख रहा है पसंद ना? Why we will not motion? कौन सी अंग्रेजी है? हाँ.
नहीं सर, मैं पूछ रहा था कि मुझे नहीं समझा कि इधर इंक्लाइन प्लेन पे मोशन अलोंग इंक्लाइन प्लेन क्यों नहीं कंसीडर करेंगे.
इंक्लाइन प्लेन मूव कर रहा है ना. इंक्लाइन प्लेन मूव कर रहा है.
सर पर उससे क्या होता है?
अबे तो ट्रेन में तू नेहरू से खारघर जाएगा तो खारघर में उतर के क्या बोलेगा कि नहीं मैं खारघर कैसे आ गया, मैं तो ट्रेन में मूव ही नहीं किया, मैं तो ट्रेन में बैठा हुआ था, तो जब मैं मूव ही नहीं किया तो मैं कहां से कहां कैसे आ गया. जब वो इंक्लाइंड प्लेन मूव कर रहा है तो उसके ऊपर जो ब्लॉक रखा है वो भी तो उसका भी तो मोशन होएगा ना.
सर अगर इंक्लाइन प्लेन मूव करेगा पर वो स्मॉल एम का मोशन तो अलोंग द इंक्लाइन प्लेन ही रहेगा ना.
अभी छोड़ दे, बाद में देखते हैं.
ओके सर.
Okay, the third case is that you have a block in free space which is under the influence of multiple forces. So this is case. Here you don't know where it is going, right? You'll have to have no assumptions, or you can have no assumptions about where the block is going to move. So M is in free space. Therefore, no constraints. And no assumptions on motion. हाँ, F1, F2, F3 का मैग्नीट्यूड सब दिया रहेगा. हाँ, अल्टीमेटली तो बता ही सकते हैं ना. F1, F2, F3 मुझे दिया रहेगा तब हम बता सकते हैं, वर्कआउट कर सकते हैं कि किधर मूव करेगा. बट डायग्राम देख के हम नहीं बता सकते हैं किधर मूव करेगा. दैट इज द होल पॉइंट. That is the whole point. Given the forces, you can work out where the object will move. No problems. What I am discussing here is that without using the given forces, can you decide where will it move? Without using anything, can you decide where will it move? Here, can you decide where will it move? In this problem, can you decide where will it move? Nothing is given to you except for the fact that there is a force F acting on it. Can you decide where will it move without any other information, without the magnitude of the force? Can you tell us where the object will move? Can you conclude where the object will move? Yeah, so we can conclude that the object will move along the x-axis. If I give you this problem, can you tell us where the object will move? Yes, M1 and M2 are going to move along the y-axis. In the third case, can you tell us where the object will move? Yes, it will move down the inclined plane. Therefore, I will choose the axis which is down the inclined plane. Therefore, it is moving along my chosen x-axis. In this case, for M2, can I tell where will it move? Just by looking at the thing? Well, no, I cannot, because I know that it will move along the x-axis and along the y-axis. So for the exact direction of motion of M2, I'll have to work things out. Right? You cannot say that the direction of motion is in the xy plane. In the xy plane तो है, but मेरे को तो exact direction of motion चाहिए ना. इनसे जो पहले 3 एग्जाम्पल हमने डिस्कस किए उसमें तो आप exact direction of motion बता रहे हो ना. और direction of motion का मतलब ये नहीं होता है कि आप मेरे को बता दो xy plane में होएगा. You have to tell me where. So for M2 we'll have to work it out. For capital M, it is obvious that it will move along the x-axis, but for small m, it is not obvious. It is going to move along the x-axis and along the y-axis, and the motion of small m is not going to be the motion of small m here, is not going to be the same as this m here, because this m is on a fixed inclined plane. Therefore, we know the direction of, but this m is not on a fixed inclined plane. Therefore, its motion is going to be very complicated, and we'll have to work it out where it is going to move, right? And here I can draw no conclusions, or there are no constraints in the motion of m, and therefore the only option here is that somebody tells me what are the values of f1, f2, f3, both magnitude and direction, and then finally I'll be able to work out. अब वो कैसे work out करेंगे, that is what we are going to discuss. कैसे work out करेंगे, that is what we are going to discuss. But here nothing is obvious and we'll have to work out, right? Okay, so let me repeat then what I have discussed up till now. If we are dealing with cases where acceleration is not equal to 0, then for every problem we will be facing 3 choices. One is that we will know just by looking at the problem what is the direction of acceleration. 2, just by looking at the problem, I know that I can really work out the direction of it. It is in the xy plane or something like that, you can tell. 3, where we will have no assumptions, where we will have no presuppositions कि direction of acceleration इधर हो सकता है या उधर हो सकता है, right? You can start with 3. So even in this first problem that I have written, जो मैंने अभी यहाँ पे आप screen में देख रहे हो, even for this you can say that no, I don't know the value of, I don't know where the acceleration is going to be, and then you can ultimately जो भी मैं method बताऊंगा, you can use that and you can arrive at the conclusion that the motion will be along the x-axis. But I think that's very, very long-winded and it will be a waste of your time, right? I mean, it would be just like I give you Shakespeare to read and you will say कि नहीं 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 मैं तो I will read it one letter at a time. तो अब आप जो है मर्चेंट ऑफ वेनिस पढ़ रहे हैं तो A M E R C. You don't want to do that, right? That is a long-winded approach. Are you right? Are you wrong? Well, you are absolutely right. Of course, merchant की आप spelling पढ़ रहे हो तो ठीक है, okay. But you don't want to do that, right? So in the same way, when you see an obvious constraint, when you see the motion is obvious going to be this, then there is a very simple way of applying Newton's laws. And if you have to work out the accelerations, the direction of accelerations, then there will be a complication and there will be an additional equation involved. And if you do not know anything, तो फिर कोई problem नहीं. Then there is a general method of approaching. So to apply second law, when acceleration is not equal to zero. Number one, draw FPDs for all objects in the problem. Number two, draw the XY axis. Okay, now here is where what I have discussed up till now comes into play, right? How do you draw the XY axis? So for the obvious constraint, the XY axis will be along the direction of motion, right? For rest, XY axis is your choice. तो अगर आपको मालूम है कि हाँ मोशन यहाँ हो रहा है, इस डायरेक्शन में होएगा, obviously then one axis must be taken along that direction of motion. But if you don't know where the motion is going to be, then it is really your choice. Really your choice. Third, and whenever I write your choice, I really mean horizontal, vertically choose करेंगे. Some cases, दूसरी choices will make more sense, but most of the time it will be horizontal, vertical. Third, find components of all forces along the chosen XY axis. 4. Summation of forces along the x-axis is equal to mass into acceleration along x-axis. Summation of forces along y-axis is equal to mass into acceleration along y-axis. Right? These are the two equations that we are going to write. And then number 5, I'll put a star here. Apply the constraint equation. ठीक है, अब ये क्या है, इसका क्या मतलब है, and why have I put a star here? So I'll go from step 5 to step 1. I have put a star here because you don't need to do this in every problem. अगर obvious acceleration वाली प्रॉब्लम है, अगर ऑब्वियसली हमें सब कुछ दिखाई दे रहा है, तो मेरे को कंस्ट्रेंट इक्वेशन लिखने की जरूरत नहीं है, राइट? कंस्ट्रेंट इक्वेशन क्या होता है, विल डिस्कस लेटर. स्टेप नंबर 4. When I have drawn the xy axis, okay, when I have drawn the xy axis, then in the first 3 cases that I drew, in the first 3 cases, case number 1, when I draw the xy axis, I know, okay, I know, and you should also be aware when you are doing the problem, that acceleration along y-axis will be 0, and therefore the summation of forces along the y-axis will be 0, right? We know this. Similarly here, the summation of forces along the x-axis will be 0. Acceleration of x-axis, acceleration along x-axis will be 0. Similarly here, summation of forces along y-axis will be 0, since acceleration along y-axis is equal to 0, right? Please notice that in this problem and in this problem, the xy axis are vastly different from each other, but the principles are the same. यहाँ पे horizontal vertical xy axis है, यहाँ पे inclined xy axis है, but इन दोनों cases में मेरे को मालूम है कि एक axis के along motion नहीं हो रहा है या नहीं होएगा, therefore forces along that axis must be equal to 0. Okay. In these cases, for m2 and for small m, right, you cannot say that force along this axis will be 0 and force along this axis will not be 0, and acceleration along this axis will be 0, and acceleration along one axis will not be 0. So here you'll have to do something else. Here you'll have to say that there is an acceleration along x-axis and an acceleration along y-axis. So for m2, for this m2 and for this m, you will have to write both the equations. दोनों equations आएंगे. बाकी वाले problems में एक equation 0 हो जा रही है. Right? So I'll show you how to do that. इससे पहले वाले जो 3 steps हैं, step number 3, step number 2 and step number 1, they are absolutely the same as the steps that we had discussed previously. Right? So whatever objects have been given to you, you draw the FBTs, then you choose the XY axis, then you find the components of all the forces which you have drawn, right? And remember that forces can act on an object due to 5 objects in the surrounding. Never forget that. FBD अगर एक बार आपने draw कर लिया, then everything else is simply maths. Okay, so let me show you how to solve this. Fifth वाला point अभी धनुष भूल जाओ, मैंने इसीलिए उस पर स्टार लगाया है. You don't need the 5th point as of now. Okay, we'll need the 5th point in the next class, and I'll repeat it in the next class. So let me show you how to solve problems here. Example number 1. Find the acceleration of m1 and m2. So we have a pulley and we have 2 blocks. m1 है ये, m2 है ये, and it is given that m2 is greater than m1. Step 1. Draw the FBDs. So I will draw the FBD for M1 and I will draw the FBD for M2. For M1, the forces acting on it are M1G T, M2G T. Okay. Now, if M2 is greater than M1, okay, if M2 is greater than M1, तो M2 किधर जाने वाला? If M2 is greater than M1, तो M2 किधर जाने वाला? जब मैं सिस्टम को रिलीज करूंगा, तो M1, M2 will obviously accelerate, and since M2 is given to be greater than M1, M2 is going to go down, right? So please notice what I'm doing. This is extremely important. M2 नीचे जा रहा है, ये मेरे को डेफिनेटली मालूम है, तो मैं इसके FBD के बाजू में, FBD पे नहीं, FBD के बाजू में मैं केवल एक एरो बना दूंगा जो उसके एक्सेलरेशन के डायरेक्शन में. नेवर ड्रॉ एक्सेलरेशन ऑन द FBD इटसेल्फ. है, और अगर M2 नीचे जा रहा है तो M1 किधर जा रहा होगा? अगर M2 नीचे जा रहा है तो M1 किधर जा रहा होगा? M1 is going up, and I will write its acceleration as A. Should I write their accelerations as A, or should I write it as A1 and A2? Should I write the same magnitude of acceleration, or should I write different values of acceleration? Should I write same values of acceleration, same magnitude of acceleration, or different values of acceleration? Well, I'm going to write the same value of acceleration because I notice one more thing. What I notice is that if this guy M2 comes down by a distance of x, right, and they are connected to each other by a string which is fixed in length, this tells me that this block will go up by a distance of x. This is guaranteed. अगर M2 x डिस्टेंस से नीचे आता है तो M1 x डिस्टेंस से ऊपर जाएगा. This is guaranteed, right? And therefore the magnitude of the acceleration of the two blocks must be same. This is a unique thing. This is true here, and it may not be true in other problems. So once I have written स्ट्रिंग टेंशन सेम रहेगा दोनों स्ट्रिंग में, सेम स्ट्रिंग सेम टेंशन. ओके, अगर स्ट्रिंग सेम है तो टेंशन सेम. प्लीज रिमेंबर दिस. आई विल राइट इट हियर एज वेल. सिंस M1 and M2 are connected by the same string, tension is same. Same string, same tension. Different string, different tension. And now I'm in a position to write the Newton's second law for two objects. So for this guy, I will write M2G minus T is equal to M2A, and for this guy, I will write T minus M1G is equal to M1 दोनों इक्वेशंस को मैं एक दूसरे के नीचे लिख देता हूँ, तो मेरे पास आएगा t माइनस m1g इज इक्वल टू m1a and m2g minus t is equal to m2a, and I will add these two equations. When I add these two equations, then t and t will cancel out, and I will get m2 minus m1g is equal to m1 plus m2a. Therefore, the acceleration will be equal to m2 minus m1g upon m1 plus. Right? This is the acceleration. अब इसमें कौन सा स्टेप नहीं समझ में आ रहा है, प्लीज टेल मी. Which step is unclear? Step 1, we have to draw the FBDs. Okay. Step 2, you have to draw the axis. I don't need to do it here because there are no components to be found. M1A होना चाहिए ना फर्स्ट ब्लैक इक्वेशन. हाँ, M1A ये तो है ना, माइनस M1A. नहीं, I have done a very yes, this result is to be remembered, yes, but I'll tell you a more superior way of solving this later. इसमें मैंने एक बहुत ही अजीब सी ट्रिक यूज करी है. वो ये ट्रिक यूज करी है कि अगर एक्सेलरेशन ऑब्जेक्ट का एक पर्टिकुलर डायरेक्शन में है, तो उस पर्टिकुलर डायरेक्शन की फोर्स मस्ट बी ग्रेटर देन द उल्टा वाला फोर्स. तो अगर m2 का एक्सेलरेशन नीचे की तरफ है, तो m2g must be greater than t. And since the two forces are acting opposite to each other, these two forces are going to be subtracted when I will find the net force. Okay. Similarly, for m1, I know that the acceleration is up. Therefore, I come to the conclusion that the upward force must be greater than the downward force. Therefore, T is greater than m1g. So I have written T minus m1g in the first case, in the m1 wala case, and m2g minus T in the second wala case. Right? As I will show you in the next class, that I don't really need to do this. There is a much more superior way of handling things. But since these kind of steps have been given in textbooks like H.C. Verma, therefore I have showed you how to do this. So this is sort of a level 1 type of solving problem. क्या किया मैंने? FBD बनाया. मेरे को एक्सिस बनाने की जरूरत नहीं है क्योंकि मेरे को कंपोनेंट्स नहीं निकालना है. ओके. मैंने FBD बनाया, कंपोनेंट्स निकालने की जरूरत नहीं है मेरे को. मैंने FBD के बाजू में, besides the FBD, I have drawn acceleration vectors. Now I know that this will be the direction of motion of blocks M1 and M2, and therefore I have assumed the direction of acceleration. And in the direction of acceleration, जो भी force है, that force I have taken as the greater force, right? And then simply I have written greater force minus smaller force is equal to ma. I'll show you another problem. क्या बोल रहा है भाई? Why do we need acceleration vectors? Yes, we do, obviously. अगर मेरे पास एक्सेलरेशन वेक्टर है तो मेरे को मालूम है ना कि कौन सी फोर्स बड़ी है कौन सी फोर्स छोटी है. सर कैन वी डू दिस टेकिंग फोर्स एंड मास रिलेटिवली. इसका मतलब धनुष मुझे नहीं समझ में आया. हाउ डू यू डिसाइड रिलेटिव मास, मतलब व्हाट डू यू मीन बाय दैट? आई एम सॉरी आई कुड नॉट अंडरस्टैंड दिस. Will there be a single acceleration in the whole system? This is not necessary. Different objects in the same problem may have different accelerations. mg m2g minus t is equal to m2a वाला step नहीं समझा. तो m2 का acceleration नीचे की तरफ है, right? This means that the force which is acting downwards must be greater than force which is acting upwards. After all, that is why it is accelerating. ना acceleration का क्या मतलब? Net force लगी है. तो अगर acceleration नीचे हो रहा है, इसका मतलब कि नीचे वाली force ज़्यादा बड़ी है. m2g force is greater than t. So therefore, the net force acting downwards must be m2g minus t, and therefore it must be m2g minus t is equal to m2a. If the strings were different, then the acceleration would be different. Yes, absolutely. And there will be problems where you will have multiple strings, and therefore acceleration, therefore tension in all these multiple strings will be different. ठीक है. माइनस m1a राधिका समझ में आ गया क्यों नहीं है? Can we use the result as a formula? Yes, we can. But why we will, that I'll tell you in the next class. A के डायरेक्शन का एरो बनाने का फायदा ये है कि मुझे मालूम है कि कौन सी फोर्स को पॉजिटिव में लूंगा, कौन सी फोर्स को नेगेटिव लूंगा. Although this by the next class will become redundant. इससे हम रिलेटिव मोशन सॉल्व जैसे g plus a and g minus a. एक हाँ, g plus a g minus a का बहुत ही डाइसी scope है, and we will discuss this at the end of the chapter, right, which is going to be a long time now. g plus a g minus a फिलहाल के लिए सोचना ही नहीं है. Okay, I hope I have answered all the questions. Let me show you another problem. Yeah, you do this. Your step. Question 1. नहीं, g10 theta नहीं है. Mass is not given because it is not going to come in the answer. हाँ शिवेन, good, yes. m नहीं आएगा पार्थ, उसमें m कहाँ से आ जाएगा? मैंने एक्सेलरेशन मांगा है ना. जोहेब, साइन थीटा और कॉस थीटा का यूनिट्स कुछ नहीं होते हैं. नहीं, गलत. चलो देखो, वेरी गुड, यस पार्थ. Step number 1, draw the free body diagram. Oh, that depends on your choice of x-axis, Bhavya, yes. नहीं, गलत आंसर. mg n. यहाँ तक किसने किया? How many people have done the question up till this thing that I have done? If you have not done this, if you have not drawn the FBD, then there are, then there is a problem. अगर आपने FBD नहीं बनाया है, then there is a problem. Okay, step number 1, draw the FBD, because you will eventually get a hang of solving these problems. What you will not be able to do later on, if you don't draw the FBD, then you will not be able to solve the problems. So whether you are able to solve the problem successfully or not, at this stage I really don't care. What I do care about is the FBD. Have you drawn the FBD or not? ये जो मैंने FBD बनाया है, आपने ऐसा FBD बनाया या नहीं बनाया? अगर आपने FBD बनाया है, तो please believe me that 90% of the question you have already done. Okay, 90% of the question you've already done. Please follow me for the remaining 10%. Okay. Step number 1, draw the FBD. Step number 2, draw the axes. So in this case, since I know that the acceleration is going to be in this direction, therefore I want to draw the axis in the same direction. Right? हाँ, बिल्कुल सही है दीक्षा जी. ये आया स्टेप समझ में? This is a crucial step for the remaining 10% of the solution. Since I know definitely that the acceleration will be down the inclined plane, therefore my choice of axis is an axis along the inclined plane and an axis perpendicular to the inclined plane. Is this understood? Is this understood by everyone? Since the motion of the block is definitely going to be down the inclined plane, my axis is also down the inclined plane. ये आया सबको समझ में? Is this understood? Next step is to find the components. Okay. So to find the component, हाँ आर्यन ये सही आंसर. So to find the components, I need to know the angle between mg and one axis. n का मेरे को component नहीं निकालना है, क्योंकि n मेरे y axis के along lie कर रहा है. तो mg के साथ मैं कैसे निकालूंगा? ये रहा mg, right? If this is mg, then obviously this angle is how much? ये angle कितना है? This angle must be 90 minus theta, right? And therefore this angle must be theta. I hope ये सबको दिखाई दे रहा है. This angle must be theta. Therefore the components of mg are mg cosine theta along the y-axis and mg sine theta along the x-axis. Now, if along a particular axis you get only one force, if along a particular axis you get only one force, this is very good because it means that whatever object you are having in front of you will have a guaranteed acceleration along that direction. So I'll write this here. So if on your FBD after after resolution you get only one force on an axis, then acceleration along that is guaranteed. क्या handwriting हो गई यार. So in this case we have mg sine theta is equal to ma. A is equal to g sine theta. So this object is going to come down with an acceleration of g sine theta. Please notice, अगर मेरे पास एक एक्सिस के अलोंग एक फोर्स है mg sin theta, उसके ऑपोजिट कुछ नहीं है. गारंटीड लिखा हुआ है, मैंने थोड़ा गंदा हैंड राइटिंग है. अगर एक एक्सिस के अलोंग एक फोर्स है तो आपको एक्सेलरेशन ऑलमोस्ट करेक्ट क्या होता है भाई? ये कौन सी फिजिक्स की लैंग्वेज होती है? If you have a force along one axis and no force opposite to it, तो आपको एक्सेलरेशन वेक्टर जैसे मैंने पिछले वाले प्रॉब्लम में बनाया था वो भी बनाने की जरूरत ही नहीं. अगर एक फोर्स है along one axis, then guaranteed उस एक्सिस के along एक्सेलरेशन होएगा. चलो, we'll continue this in the next class. No homework for today. You can start with HCV, Newton's laws of motion. You can do the first 5 or 10 questions if you wish. They are simply formula based problems. F is equal to ma में F दिया है तो A निकालना है, F और A दिया है तो M निकालना है. Try them out and I will show you the immediately प्रसन्ना बिल्कुल. नहीं, अभी मॉड्यूल अभी कुछ नहीं. mg cos theta का यूज है राधिका. I could have asked what is the normal reaction between the block and the inclined plane, and since there is no acceleration along this axis, this means that the forces along this axis must be 0 and therefore n must be equal to mg cos theta. Okay, chalo. हाँ, नोट्स में अभी आज के और कल के दोनों में पिछले पिछले उसमें भेज दूंगा। लेक्चर 2 तो करना ही है। हाँ, लेक्चर 2 तो करना ही है। हाँ, मैं देखता हूँ, अभी देखता हूँ कुछ। मुझे क्या करना है। चलो, बाय बाय।